Hello, my name is Jonathan Rivas. Today I'll be solving problem 2.58. The problem reads, consider an equilateral triangle inscribed in a circle of radius A with a point charge Q at each vertex. The electric field is 0 at the center, but surprisingly there are 3 other points inside the triangle where the field is 0. Where are they? Alright, so to start with this problem, let's first draw our circle. We need, right, in the center, let's draw our coordinate system. The coordinate system is going to be an XY plane, where Z is equal to 0 because, you know, there's no way for the electric field to be, there's no way for there to not be an electric field outside of the XY plane, since, you know, electric field Z doesn't equal 0, or, you know, Z doesn't equal 0, so we're going to set Z equal to 0. We're going to focus on the XY plane. There's a few ways we can draw this equilateral triangle. You can start from one point and then, you know, draw your triangle. I'm going to start with my vertex, one of my vertex here. So that means the other two will be over here. Right, and that will be my triangle. From here we can see that our coordinates will be something like this. This point is going to be negative a half 3, rather 3a over 2. This point's going to be negative a half negative 3a over 2. Right, let me write up these coordinates so you can see them. Yeah, this will be for one of the vertex. This will be for the other one. This will be for the last one. Okay, and we have radius A. So because we have symmetry in our favor, we really only need to find this point for solving one of the electric fields, or the magnitude of electric fields for one of these points. So I'm just going to pick this one right here, and that distance from wherever we find from the other point in our triangle is going to be the same for if we were to do the other ones. So I'm going to call it EX total, and from there we can see, let's see, well, for sure going to have Q over 4 pi epsilon naught. Then let's see, we're going to have X minus A, X minus A squared, we have, yes, plus 2x plus A over 2, right, X plus A over 2 squared, squared, because they're squared, we have 3a squared over 4. And these are coming from our coordinates, right? This is going to equal to 0, right? Because we're trying to find the other points inside the triangle where field is 0. This is really the magnitude. Yeah. could simplify it a little further. Let's see. So it'll be 4 pi epsilon naught for q. And x minus a third x minus a plus 2x, let's see, so 2x plus a, right, I'm going to have x squared plus ax plus a 3/2. Right, it'll equal to 0. Alright, so now let's consider, in order to make this a little more simplified, let's consider a new integer. We're going to say m is going to equal to x over a, and that the absolute value of x is going to be less than that of a, right? We can have our this to be outside of our point, right? Outside of our circle, we have to be inside our parameters. So we're going to set this as a conditions. And then if you plug this in and do some more simplifying, some algebra, we're going to have bit of 1 m minus 1 squared plus 2m plus 1 m squared plus m plus 1 3/2 is equal to 0. So from here, we're really just interested into this part, right? We need to, in order to find that point, we need to set this, we need to find when this is equals to 0 and solve for m. The problem gives us an answer. It tells us to use a computer. You can use Mathematica, Desmos. I use MathWays. You basically just have to plug this into the computer, and once you do, you'll have, let's see, let me go back and find this. Yes, you have two complex roots and one negative root. So the two remaining solutions is shown to be m equals 0.284718 and m equals 0.626691. The latter here, you're going to be outside of your triangle, so that's not going to be it. So the other points inside a triangle where the field is 0 is going to be r equals 0.284718, right? And the other two places where the electric field is equal to 0 are at the symmetrically located points from this. So yeah, this will be where you will find it. And that's it. Thank you for watching.